Hey. Hi, everyone. Thank you very much for coming to this talk. My name is Nicola Corti, and today we're going to talk about Detekt, State of the Union. So, mandatory slide about myself. I'm a Kotlin Google developer expert. I'm one of the maintainers of Detekt. That's also why the reason why I'm here today. Those are my social. You can find me on GitHub and Twitter as Cortinico. I also love to run marathons. Generally, I love running. And I'm also running a podcast. It's called The Developers Bakery. You can find it on Spotify, Apple Music, Google Podcast, or there at thebakery.dev. It's about open source. And as you will probably understand towards this talk, I really love open source. But before we deep dive into Detekt, as I said, I also love running. I recently had the opportunity to run the London Marathon. If you were following me on Twitter, probably you know a little bit about it. I was running a fundraiser, so like collecting money for charity. And well, I happened to have some leftovers, so I want to run a little giveaway. So I prepared some amazing sticker sheets that I have with me today. And I know that you all want one, like especially these, it works on my machine. They are amazing, aren't they? So yeah, and they are here. So I would love to give them away to people that are opening pull requests towards Detekt toward the day. So just open a pull request, come to me and show me, and I will give you one. So yeah, I have still some, and I'll be happy to give you one. So that being said, there was intro. It was quite long. So let's deep dive into the topic of the talk. So what is Detekt? How many people in this room are actually using Detekt on your project? Quite a lot. So for those of you who are not using Detekt yet, Detekt is what I like to call the static analyzer for Kotlin. It's a collection of inspectors that are running on your Kotlin code and are trying to help you write cleaner code, finding if there are problems, potential bugs, and so on. We recently also got a new logo. So I hope you got the reference of the double bang in the logo. That's our goal. We search for problems in your code. And you can find us on GitHub, on github.com/detekt/detekt. And yeah, it's, as I said, the static analyzer for Kotlin. It's quite popular, not super big, but for being like a static analyzer, we're quite happy of the involvement that we got in the community. Like we keep on having a lot of pull requests and so on. Thank you. And yeah, we released version 1.18.1 like in end of August. So version 1.19, it's due really soon. I will talk also about it towards the end of the talk. But today, I want to give you an overview of what Detekt is, what we do, what is the roadmap for the future, and the ecosystem that Detekt is offering you. So at the core, Detekt is a collection of rules. I think that at the time of writing, I counted nearly 220 rules, but now we have a bit more. We are like nearly 230 probably. And those rules are basically like little inspectors that will check your Kotlin code and will tell you, hey, that might be a bug here, there might be a problem, and so on. So if you're already familiar with Detekt, you probably know what is a rule. But if you're not, I just want to walk through some of the rule sets that we offer. So given that the rules are like a lot, we group them in these sets called rule sets, and we try to give them meaningful names. It's not always easy, but yeah, let me walk you through some of them. Comments. Here we have rules related to documentation and comments, like check if you're documenting public functions or so on. Complexity are rules that are, as the name says, helping you understand if your code is too complex. Like maybe your functions are too long, too many nested blocks, and so on. Coroutines, we have some rules that are specifically designed to help you write coroutine code that is clean and works properly. Empty blocks, well, we check if you're having empty blocks that should not be there. Exceptions, those are rules that are checking how you're using exceptions. So if you're throwing exceptions that are too generic, or if you are like maybe having a too wide try-catch block, and so on. Naming is a set of rules that is helping you name function correctly, function properties, following rules that you can specify. Performance, we do have some rules that help you discover if there are like performance regressions in your code, or like using certain operators or functions that you should not use or you should avoid. Potential bugs. So this is one of the biggest rule set, and there we have, yeah, like a lot of inspection that tries to understand if in your code there might be a code smell, like something that could lead to a potential bug in production. And then actually the biggest rule set is style. And you don't need to read those name of rules, but we have several rules over there. And again, those are rules that help you with the style of your code. So generally writing clean code and so on. We use style as a name here for like, we weren't able to find like a better name, but yeah, those are like probably our biggest rule set. I want to spend some time to present some of the rules, because later in the talk I will deep dive into the internals of Detekt, and having some examples of some rules is useful for the sake of the discussion. So there is one rule, it's called unused private member, and what this rule does is quite obvious. It checks if there is an unused private member. So in this case, I have this class with two members, a member and another member, and I have a main function and I print one of the two. And Detekt will tell you, hey, you're not using this guy. So private property, another member is unused, and maybe you should remove it, or it should be public, or I don't know why you added that there. There is another rule. I think it's probably one of the most famous rules in Detekt. Like in all the companies where I worked, this was like, people were like extremely pissed about this one. It's called magic number. And the idea behind this rule is we try to check if you're using a number in your code that has no real meaning and it, like makes the code harder to read afterwards. For example, if you have a function and you check if a number is more than 42, Detekt will tell you, hey, this expression contains a magic number. Consider defining it to a well-named constant, like val answer equal 42. So we have several rules, and you might wonder, okay, some of those are obvious, like unused private member, but others might not be so obvious. So how do I understand what a rule is doing and what's the goal of it? So we do have some documentation. So every rule is actually a Kotlin file that you can open, and every rule is properly documented, I would say. Like we do have a big kdoc section on top that tells you, hey, what this rule is doing. For every rule, generally we try to have a non-compliant and a compliant block that gives you two snippets of code that are either triggering the rule and the solution to that snippet to resolve the rule. And then recently, we also did a revamp of our documentation, and we moved to using annotations. So you will see that rules are annotated with some metadata. Like in this case, we have an annotation called active by default since a version. So this rule is active by default. It means that if you set up Detekt, this rule will run and will check your code. Not all the rules are active by default. So this documentation translates to our website, which is really simple. We're looking for improvements, so if you want to help us, please do. But at the end of the day, they render over here, and you have like a nice section of what the rule does. For example, here is active by default, yes, since version 1.0.0, and for most of the rule, we also offer some configuration options. Like you can configure how the rule behaves. For example, for magic number, you can say like, hey, if the number is, I don't know, 100, I don't want to be reported because in my code I use the number 100 a lot of times. I don't know. And also here you can find the snippets. So far, so good. So I mentioned that some rules can be enabled and others can be disabled. How can you enable or disable a rule? So there is a detect configuration file, is a YAML file that generally lives at the root of your project or wherever you want. And it has like several keys, and for every rule, you have a block where you can specify how the rule should behave. In this case, this is the configuration for magic number. And here you can specify if the rule is active or not. So you can actively enable or disable rules. Let me give other examples of other rules. So there is another one. It's a little bit more complex. And it's called unnecessary not null operator. So this rule is checking if you have a not null operator that is unnecessary. Quite obvious. But let's check this code. So you have val 0, and there is 0. And then you call a double bang on this. So what's the type of 0? Well, we read this code, and we say that the type of 0 is int, because it's super easy. And IntelliJ will also tell you with like this little type hint. But if you just give this code to a machine, the type is not explicit. So it needs to be evaluated. Detekt has this power to understand types. And here we'll tell you 0 contains an unnecessary non-null operator and can be removed. You don't need to do this code. The reason why I'm presenting this rule is because this rule is a little bit more powerful than the other I showed before, because this rule has the concept of types that are crucial for how Detekt works internally. I'll get back to this later in the talk. But let me present a couple of other rules. So another one that I really like, it's double mutability for collection. So if you know the book, Effective Kotlin, this is one of the item that is presented in the book, and we actually converted into a detect rule. So what is this rule doing? If you have something like this, var obits equal mutable list of, blah, 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 Detekt will tell you that here you have a problem, because variable obits is declared as var with a mutable type, mutable list. Consider using val or an immutable collection type. So you are introducing a double mutability here. Like you have a mutable list and then also you have a var. So you could either clear the list or you can even recreate it. That is not great. Like you should try to use immutable values, not mutable and not even double mutable like this one. So the reason why I'm presenting this rule is because I like to think as Detekt as the tool that basically bridge the gap between the theory, like a book, and your code. You can write custom rules to let your code behave and look as you wish. Like how many times you read articles on Medium that are telling you, hey, you should not do this, you should not do that. But then in reality, when you write your code, you find like thousands of occurrences of that pattern that you wanted to avoid. Detekt is actually there helping you writing cleaner code and just following the pattern that you want to follow. Another rule that I want to present is the forbidden method call. And it's a rule that is checking if you have a forbidden method. In this case, this rule is not active. So if you would search through the config file, you will see that this is active false. And the reason why this rule is not active is because it's a rule that Detekt gives you, and it's up to you to configure it as you wish, and it might fit your use case or not. So what you do, you activate it, and you need to also to specify the list of methods that you want to forbid. So this rule will help you if you have a code like this, and will tell you, hey, print line, the method Kotlin IO print line string has been forbidden in the Detekt config. So you told me, you enabled a rule, and you told me that those two methods are not allowed, then now I report it. When this rule is useful, this rule is useful if you have some methods that you don't want your developer to use. Maybe you have your own logger, you don't want people to use print line, or so on. And instead of going through the code and manually searching, yeah, that works. You do your refactoring once, okay, but then you want to forbid this kind of method calls in the future, then you use this rule. You enable it, and you specify the fully qualified name of the methods that you want to guard against. Obviously, you can suppress, as Android lint is doing. So if you have a valid section of code where rules should not be triggered, you can use the suppress annotation at the call site or on any block that is in your hierarchy. So like the function, the class, and or so on. Or you can also suppress for the whole file using the qualified file annotation. So how do you use Detekt? There are multiple ways to get our tool and to start using it in your code. The most simple and naive way to use Detekt is to use Detekt CLI. So for every version of Detekt, we actually publish on GitHub some assets. And one is a jar that you can invoke with java-jar. And it just runs. It expects Kotlin code in input, and it prints out if there are problems. Fun fact, you can actually also brew install Detekt, and you can launch it from your command line. Maybe you have some files or, I don't know, some use cases for these. But if you're an Android engineer or if you have like a Gradle project, you generally want to integrate Detekt inside your builds. So now also I want to spend some time a little bit on custom rules. As I mentioned before, you can extend Detekt to provide your own findings and like your own inspections. And I think this is valuable for some, like especially if you have a bigger org and you have like a lot of developers, you might want to customize Detekt behaviors in some form. So let me explain you how you can do it. And to explain this, I actually want to use an example of custom rules that we Detekt maintainers are offering to the community. And it's integration between Detekt and Kotlin lint. So I intentionally added this slide because I wanted to clean up a little bit of the confusion. And naming is really hard, apparently, because Kotlin lint is not a linter, it's a formatter. So, and Detekt instead is a linter. What we offer inside Detekt is a Kotlin lint wrapper. So you can run Detekt, and you can tell Detekt to also run Kotlin lint for you. So you have only one tool that runs both for you. The way how we offer this integration is through some custom rules. So we use the Detekt extension API to offer this to you. And they are actually the only rules that offer autocorrection. So at Detekt, we believe that we don't want to change your code. So all the rules that Detekt are offering are just like, they check your code and will tell you, hey, this is wrong. You need to fix it. But Kotlin lint instead is a formatter, so Kotlin lint is actually editing your code. So Detekt has the support to write your rule and to give you the capability in your custom rule to edit your code, and this is what Kotlin lint is doing. So you will find that there is a formatting rule set that is actually the Kotlin lint wrapper, and as the autocorrect property that you can specify to true or false. And that will, if it's enabled, then some Kotlin lint rules also have the capabilities. For example, if there are like empty lines, Kotlin lint can fix that. Not all the rules can do that. So on this side, I actually want to clear up a confusion that people have. So we do have the formatting rule set, the Kotlin lint wrapper, and we also have the style rule set, our first-party Detekt rules. And there are some rules that like sort of overlap each other. For example, the wildcard imports and the no wildcard imports. Well, this can be confusing because this is a rule from Kotlin lint, and this is a rule from Detekt. So what's the deal behind this? Like, try to pay a little bit of attention when you configure your Detekt file, because if you enable everything, you might end up seeing double reports. The Detekt rules are rules that are offering configuration options. Like they're more like granular. You can control them better. While the Kotlin lint rules instead, and here I have another example, unused imports and no unused imports, the Kotlin lint rules are the only one that offer autocorrection. So if you want to autocorrect your code, you need to use Kotlin lint. So just so you know that those tools are like They work together, but you need to know what, like, how they interact. So let's say that instead you want to write your own custom rules. How do you do? So you need basically a Kotlin JVM module, like a pure Java module, and you need 3 files, basically. So you need the rule, and the rule is a subclass, like your custom rule will be a subclass of rule, of Detekt. You will have an input, a config file, where you can read the keys, like maybe you have your own configuration for the rule. Then you have a rule set provider. This is really similar to what also Android Lint is doing. So you have like a class that is responsible of providing the list of all the rules. Like you might have one, but you might have more. And this basically creates a rule set, my rules, or you can call it as you wish. And then we use the service provider from Java. So you need a file inside the meta.inf folder with the fully qualified name of your rule set provider. And that's it. It should magically work. If it doesn't, just like we saw that there are people that are having problems configuring this. We do have documentation on how to do that. But just like go on our issue tracker, open an issue, or come on Slack. We can help you over there. And how do you effectively write your custom rule? So your custom rule is written using the visitor pattern. So once you have your rule, you can override one of these visit functions. And those visit functions, they are from the, basically the Kotlin PSI API. So you get access to an abstract representation of your Kotlin code. So for example, if you want to check, if you want to write a custom rule that checks if the name of a function is, I don't know, as a prefix of your company, for reasons, like you will have a visit function somewhere, and you will have access to an object that is a KT function, and there you can check what's the name of the function, what are the parameters of the function, and so on. So here is where the pain lives. This API is from JetBrains, is really undocumented, so it's a little bit painful to write custom rules the first time. My suggestion is go to the Detekt code base, try to search for a rule that is similar to what you're trying to achieve, and try to emulate that behavior. Sometimes there are like a lot of rules that are really doing something really similar to what you want to do. Or if you don't find anything, just come on Slack, open an issue, open a discussion on our board, and we will try to help you as much as possible. So previously I was talking about Detekt CLI, and I mentioned that, yeah, some of you might be using other tools to run Detekt, like Gradle or even IDEs and so on. So now I want to present some of the tools and the integrations that are part of what I like to call the Detekt ecosystem. So we are not just a static analyzer. We try to integrate inside the suite of tools that any Android engineer, Kotlin backend engineer, Kotlin multiplatform engineer might use, because at the end of the day, this tool is not just for Android developers, it's for anyone that is writing Kotlin code. So first, we have a plugin for IntelliJ or Android Studio. So if you go through the plugins, you will find one, it's called Detekt. And this plugin basically just allows you to run Detekt in your IDE. Yeah, it's quite minimal, but it works in the way that you Detekt will run and you will see inspections directly in your code. So if there is a warning, you will see which line that warning is fired. We also recently worked a lot on the integration with Sarif. So if you're not familiar with Sarif, Sarif stands for Static Analysis Result Interchange Format, and is a way, it's a standard used by static analyzer to exchange information. So this standard is fully available. Is an initiative kicked off by Microsoft. But the idea is that like when you run Detekt, you get a report that can be like an XML or a HTML or a TXT file or a console report and so on, or you can get a Sarif file. And the Sarif file can be uploaded to GitHub, and that will show up in the code scanning of your repo. This means that basically you can get, like if you go in the code scanning results, you will get like alerts. Now they're all collapsed together, but they will actually appear in line in the pull request, like where this issue got triggered. So as I said, we're trying to integrate into this ecosystem. We also have like a plugin for SonarQube. So if you use SonarQube for code analysis of your code base, we integrate also there. Last week, JetBrains announced Codana. There is their basically solution, JetBrains approach to like server static analysis like SonarQube is doing. We don't have an integration for that yet. So if you want to help us build it, please drop us a message. Yeah, just one little note. All those tools needs to be developed and maintained like in the free time of people. So if you use them and something doesn't work, I know that open source is demanding, but at least please spend the time to open an issue and tell us like what is not working and try to create a reproducer or so. Now I want to spend some minutes to talk a little bit about type resolution. So type resolution is this thing that it was in our GitHub issues and pull requests for a long time, and people, I have the feeling that people never really understood it completely, so we spent some time like explaining it. And I also want to spend some seconds talking about it. So previously I presented two rules. One is magic number, and another one is, yeah, there was reporting this 42, and another one is this unnecessary not null operator. So, and the idea is to check this double bang. What's the deal here? Those two rules are rules that are fundamentally different. The one on the left is a rule that works at the syntactic level of the language. So this guy is just checking the tokens, like this is a open parenthesis, close parenthesis, this is like a number, and so on. And just by checking the syntax of your code, we can say like, hey, this is a number placed there in the middle, and it feels wrong. While this thing over here needs to have a little bit more power, needs to know type informations. So in this case, if instead of having 0, I have a function called get a number, what's the type of 0 now? Well, it depends at this point, because it can either be int, nullable int, but by reading this code, it can be anything I mean, if this code compiles, it can be any type that has a plus function. And, well, Detekt is not able to tell you anything else, like if this double bang is valid or not. So the deal here is that unnecessary not null operator needs to know the return type of get a number. And the problem is that if get a number is defined just below here in your file, well, that's easy. But if get a number is a function that comes from the AndroidX library, well, then I need to know about AndroidX, about the library. I need to know the types of that function over there. That's why we have rules that are working with type resolution. And again, for every rule, we have an annotation that is called requires type resolution. And this is also like available on the website. And I don't want to deep dive too much into type resolution, but the rule that requires type resolution access a field that is called binding context. And this field is where the type information lives. So all the rules that requires type resolution, also your custom rules, need to have this statement. They need to check if the binding context is empty, and if it's empty, that rule can't do anything. Like, they don't have types, so this rule is useless, basically. And here, like, there is a gotcha, because those rules, like, you might run Detekt without type information, and a lot of people comes to our issue board, and they say, like, I enabled this rule, but it's not working. And it's like, yeah, because that rule requires type resolution, and you're not giving types information. So again, everything, you will find in the documentation if a rule requires type resolution or not. But then people would say, like, yeah, how do I enable type resolution? Well, we also spent some time writing a page about it. And the early way to enable type resolution would be like, hey, yeah, you need to specify the class path and JVM target. And then people will come on our issue board and it's like, the class, but what exactly do you want from me? What do you want the class path? So the reason why I want the class path is that I need to know all the libraries you are using. Like, I need to know all the dependencies because the types are also there. But, well, we don't want developers like you to specify a class path that is like a super long list of all the jars used to compile. Like, that would be mean. So what we do this magically for you inside Gradle. So we also offer some plugins. The most popular one is the Detekt Gradle plugin, where we take care of this wiring. Specifically, like you will go in your build and you will specify our plugin and the version, and yeah, like you need to have Maven. Like we are Maven Central, and you can specify this Detekt block where you can say like your config files and all the configuration for Detekt. So this is a really blank Gradle project. So if you try to search for all the tasks, you will find that there are 3 of them. The first one is the Detekt task. So this just runs Detekt. Then we have a Detekt baseline that creates a baseline of all of your issues. So it just like runs Detekt, finds all the errors, puts them on a file, so that the next time you run Detekt, you don't need to fix everything at once. You can use the baseline to suppress things. And we also have a Detekt generate config file task. This will generate the config file and put it in this place that is specified. Well, this is a really blank Gradle file because you're not applying any plugin. So if you start using the JVM plugin, well, then you will see that we have a little bit more tasks for you. Specifically, now there is a Detekt baseline main and Detekt baseline test, and a Detekt main and a Detekt test. And here I want to deliver basically the most important point. All the Detekt tasks that have like a source set in the name, like Detekt main, Detekt debug, Detekt test, Detekt whatever, they are running with type resolution enabled. The plain Detekt task, that just Detekt, that is running without type resolution. Why this is a thing? To explain why this is a thing, I will take an Android project that is a little bit more complicated. So now we have the Kotlin Android and the Android application plugin. And well, if you start to search for tasks, you will find that there are a lot of them. A lot of them. So we have Detekt debug, Detekt debug Android test, Detekt debug unit test, and release unit test, and so on. So why we do this? Because we need to know the class path. We need to know which dependencies are inside the debug, which dependencies are inside the release, which dependencies are inside your tests, and so on. On Android, you can have like an implementation, a debug implementation dependency, a release implementation dependency, and so on. And Detekt needs to know those information to run with type resolution. If you don't want to run with type resolution, then you just use the plain Detekt. And yeah, it's up to you. Our recommendation is to start looking into type resolution because in the long run, we really want to have type resolution enabled for everyone because this gives us more power, rules that are having more fine-grained inspections. Yeah, so we also recently released the Kotlin Multiplatform support. So if you have a Kotlin Multiplatform project like this one, and you use the Multiplatform plugin, with like multiple targets like JVM, Android, iOS, and JS. And yeah, you start for search for tasks. Well, we need to do the same stuff. So a lot of tasks. It could be confusing, we understand. And this is like, we released it recently. So we are looking for people that are willing to test our multi-platform integration and tell us if it's not working for them, if we can improve it, or yeah, just give us your feedback. And now I want to spend like some last minutes to talk about the future, like how we envision things going forward and yeah, like what comes next. So the first one is, as I said, version 1.19 is overdue. Actually, yeah, we have a bunch of things to release in this next version. The first feature They've been developed by that guy here in the front row. There is another maintainer of Detekt, so please come complain to me or to him if you don't like this feature. But if you do Jetpack Compose, you will like it for sure. So we are adding the ignore annotated key to all the rules. And this will basically allow you to specify an annotation, and we will basically ignore that reporting of a rule if we find the annotation is specified in any of the block in the hierarchy where the inspection is found. Why this is important? Because, for example, magic number, like especially now with Jetpack Compose, that a lot of the layout code moves from the XML to the Kotlin code, you end up having numbers in your code. And while magic number is still valid for most of your business logic, it might not be reasonable to have it in all of your composable functions. So you can say like, hey, yeah, if there is a composable annotation, just ignore this rule there. We are actually also looking into other ignore capabilities. For example, maybe you can specify ignore functions, and maybe you have a function name, and I don't know, like there are other frameworks also, like Dagger use cases where you don't want a certain rules to be triggered inside a module or so on. So we're looking into those. We're trying to take Detekt as platform agnostic as possible. So we don't want to bake inside the rules the concept of Jetpack Compose, but we are trying to offer capabilities like this one that are like making this tool a little bit more flexible. And another big change that we are shipping is we are changing how the reports configuration work. So historically on Detekt, you will specify the reports in this way, like using Detekt reports, XML, and you will specify destination. So this is like, this was designed when Detekt had only one task. But now that we are growing the number of tasks, well, there is like a bug in this approach. The problem is that every task is reading this information, and you might end up in a situation where every Detekt debug, Detekt release, and so on, Detekt task, they will all read and write inside that file. So they basically all override each other. That is not great. It's not great because you end up having one file that is the file of the last task that executed, and it's also not great for Gradle reasons. So we are actually moving this configuration at the task level. So there will be documentation on this. But if you have been like affected by a problem with the reports, this might be potentially solve your issue. Then I also want to talk a little bit more of the long vision of what we are ideally we would like to deliver. So right now, when you run the check task, well, this task is running build and running stuff for you. So at a certain point, you will also call the compile Kotlin task that will compile your code. And also, we plug the detect task inside check. So if you just call Gradle check, you will also run Detekt, the one without type resolution. Well, as I said before, we are pushing for type resolution. So we will really love to call like Detekt main or any other task that has type resolution. Well, what's the deal with type resolution? The deal is that type resolution is essentially running another compilation internally. So we get your class path, we get all of your file, and we pass it to the Kotlin compiler embeddable, and we basically, compile your code twice. There's really not great. So we would really love to compile only once. And there is also another subtle problem that the compiler flags might end up being misaligned between those two compilations. So you might end up running Detekt with some flags that are not the same that are used here. So you will see warnings that will not make sense to you. And yeah, and it's just like extremely painful to get the class path every time. So what's the deal? We are working on the Detekt compiler plugin, and I think this will be like the future for Detekt, hopefully. So the idea is that hopefully nothing will change for you. You will just have to change the ID of your Gradle plugin, and what will happen here is that you are not running Detekt as a separate task, but we are just injecting our code inside the compilation. So this means that when you call Gradle check, and you call, like you end up compiling, and the compiler will also invoke Detekt internally. So this means that we have access to the intermediate compilation output, and we can see, we can have a view of the code that is as closer as possible to what the Kotlin compiler sees. And this is just great for a variety of reasons. First, because we don't compile twice, which is way, way faster than how fast Detekt is now. And yeah, type resolution is just close to the production code. And well, we can also get rid of all those custom tasks because we don't need Detekt debug anymore. We don't need Detekt release anymore because there is a compile, there is an assemble debug that is calling compile the compilation internally. So that will simplify a lot of work for us, for your Gradle graph, like you will have way, way less tasks. And yeah, everyone will be happier, hopefully. But at the end of the day, when you call like assemble, with the, if you use the Detekt compiler plugin, that by the way is already available, you can play around with it. It will look like that. Like you will see that the compile Kotlin task failed because there is a warning found here, and it's a magic number. And so it's not a failure of the Detekt task, it's a failure of the compilation. Yeah, so that's all for me. I think I'm a bit late with time, so yeah, I just want to thank everyone in the community that helped us shape this project. Where are we? So you can find us on GitHub Detekt, Detekt on Kotlin Lang Slack. The website is Detekt GitHub.io. Open discussions, please. Open GitHub issues if you have problems, and so on. You have a contributing.md file that will help you get started. And yeah, a lot of people ask me, what can I do? Like, I want to do open source, tell me. And well, I'm overwhelmed by the amount of things to do, but let me go through again what you can do for Detekt. Search for the issues labeled as help wanted. We have tons of them. We just don't have the time to do everything. Update documentation, add tests, really. Submit new rules ideas. Maybe you have a pattern that you found in your code that you want to track, and so on. Fix false positives, false negatives. Those are like the easiest thing to jump in. Like someone reports, hey, this rule is flagging this code and it should not. And those are quite easy fix to do. Help with integrations. Maybe you're good with Gradle. You like doing IntelliJ plugins. Help us, please. Test new versions. All new versions are available as snapshots. So just try them and tell us if it's blowing up and why and where. And also, we need a lot of help with branding and marketing. Like if you want to help us, I don't know, have a Twitter account, and I don't know, just have some graphics that are a bit cooler than what we have right now, we will love your support. Who is Detekt? Well, Detekt is the community. Like, there is no company behind this thing. And I am amazed by how many people are constantly pushing code to us. And well, I wish your face will be here the next time I give this talk. And with these, well, thank you very much. Contributions are more than welcome. Yeah, just drop us a message, and thank you very much for listening.